So, hello, my name is Mike Panacki, owner of Network Protocol Specialists, LLC, here in Seattle, Washington. So for the last 12 years, we've been delivering the Fluke Networks Certified Cable Test Technician program. So we've traveled around, done the training. We're doing the training online right now, especially with COVID. As you see behind me, there's a whole bunch of Versiv testers. So we have it set up so that when people take our classes, they can remote into the Versivs using a web browser. They can do it from their phone, a tablet, or from their computer and do the hands-on exercises as far as setting the tester up and taking a look at test results. So in this session, we're going to focus mainly on what happens after we run the tests. So in this case, I'm going to come in and I am going to share LinkWare Live. Now, there's a couple of different ways to get the test results off of the tester. In this case, we're going to start by taking a look at LinkWare Live. I did a few quick starts this morning, and we covered doing copper testing. We covered doing fiber testing. And we showed how we can come in here to LinkWare Live, set up the project. We can then go out to the tester and pull that project down, run the tests, and upload the test results. So whether you're an installer, a network owner, or a customer that's having cable testing done, it's important to understand what's being presented in the report that you get after that testing is complete. What's really important as well is making sure that you set up the right testing standards ahead of time. So prior to going in and having the testing done, we want to make sure that you are calling out the proper test limits, cables, and we prefer to see that people that are going in to do this testing are CCTT certified on the Fluke Networks equipment. What this says is that they've gone through, if they've done both copper and fiber, 14 hours of training on how to properly set these tools up, run the tests, and upload the test results. So in this case, what I've done is I've gone in and created a sample test report. So if we come in to LinkWare Live and we take a look at our test results right here. These are our test results that we collected from some samples I did in preparing to do this presentation. Now, with LinkWare Live, we're able to upload via the internet the test results from the Versiv up to the cloud, and we can log in and get to these results. Now, from LinkWare Live, we can either generate the report or we can download the test results into LinkWare PC. I'm going to begin by generating the report from LinkWare Live. Then we're going to go over and generate the report using LinkWare PC. If you're having testing done, in addition to the PDF report that you may receive or the printed report that you may receive from the people doing the installation, we strongly recommend that you request the FLW file as well. And this is the Fluke LinkWare file. This file gives much more detail into each one of the tests than we see with the PDF or printed report. I will show you how to go in and download that FLW file, and we'll look at how we import that into LinkWare PC. So if you are a customer, you can download LinkWare PC for free and then import that LinkWare file. So it's just important that you have access to that information that's been collected on the network that you had installed. So in this case, for my sample report, I'm going to click on Generate Report. Now what's happening in the background is LinkWare Live is generating a report that contains all this information in it. And so I'm going to get an email here in just a second with that report download link on it. So again, as we're going through today, questions are incredibly important to me. This is a great opportunity to ask questions. This is a live session we're doing right now. Pretty good size report, so it's taken a minute to download. While we're downloading that report, I guess I could come out here and I could go to my test PC, and we're going to go ahead and log into that PC. And we'll fire up LinkWare Live on there as well. All right. Okay, so let's see if we've got that report yet. There it is. So I'm going to bring this email up. So after I clicked on Generate Report, I get this email and it says your report's ready. So now I can download that report. So here is our sample report right here. So this would be a representative sample of what we might get from a contractor that's gone in and installed our cabling system. Up here at the top, we can see that this report was generated by LinkWare Live. I went into LinkWare Live and changed the logo. So we've got my company logo in there up at the top. Here we see who the report was generated for. Now, right here, this is some of the most important information that we can gather about the report right at the beginning. So what this is showing is which modules were used to generate this report. So in this case, we saw that an OptiFiber Pro quad module was used, a CertiFiber Pro quad, CertiFiber Pro, DSX 5000, DSX 5000. Gives us the serial numbers of those. It tells us the current firmware. Now, this report was run, these test values were done several months ago. At that time, version 6.5, build 5 was the current version. Now I've got kind of a special version on my modules that we used for doing testing, but right now the current version of firmware is version 6.6 build 2. So one of the first things I look for when I'm going out and looking at test reports is what version of code they had on their modules. Here we see 6.5 is the current build. So we could go out to the Fluke Networks website. We could go to Support, Downloads and Updates. And from here I see 6.6 is the current version. Now at the time this test report was done, 6.5 was the current version. So it's a good idea to ensure that the people that are doing the testing are using the current version of firmware. In fact, it's a good thing to call out in the testing contract that they need to make sure that they are using the most current version of code at the time the test is run. Now the next one is calibration date. Now we see right here that the calibration dates are a little old on these. Now these are modules that we have in the studio that we use for training. Now we're not going out and doing professional testing with these. We're using these to do training classes. So we don't use up calibration time at the service center calibrating these modules. It is Fluke's recommendation that these modules be calibrated annually. So what we're going to expect to see is that there is no more than 12 months between the date that these modules were calibrated and the time the test was run. So we will go in and take a look at that on the individual reports. So in my case, they're way out of calibration. We don't use these to test networks in production. These are only used for training. So we're going to come in, we're going to scroll down. So here, the next section we see is each of our cable IDs. We see a summary, whether that passed or failed. We see which test limit was used. We see what the length is, the headroom, and the date when this test was performed. So I did a lot of this testing on October 14th, 2020. So this shows us an overview of all of our tests. Now we're going to talk more about the test limits and the information that we see in there as we go down. Now, if you're having fiber testing done, and they are using the CertiFiber Pro to do that fiber testing, it is critical that we see at least 2 of these TRC values in here. This is our test reference cords. So when we're doing fiber testing, we are using test reference cords, encircled flux test reference cords for multi-mode and regular test reference cords for single mode with the CertiFiber Pro. As part of setting reference, these test reference cord verification values are saved in the test records. If these are missing, this can indicate that reference was not set properly and the test results are not accurate. So this is one of the other things that I look for when I'm looking at a set of test records, is if fiber testing was done with the CertiFiber Pro, do we see the TRC values? Now, it could be that in this case, we ran into some challenges could be run into in setting reference. And that's okay. It happens. But in the end, we want to see a set of TRC values where reference was set properly. So let's continue down on our report. Here we can see the total length of cable that we tested, the number of reports, number of passes, number of fails. Ideally, we don't want to see any fails in here. We continue down. Now, here is where we have done a OptiFiber Pro test. So this is an OTDR. We're doing our optical time domain reflectometer test, and this is a bidirectional test result. This was done using the Smart Loop test on the OptiFiber Pro. What Smart Loop allows us to do is do bidirectional testing from one end of the fiber without having to take the OTDR to the other end. We do this on 2 fibers at one time. So up here at the top of the report, here I'm looking at what the date and time is that the test was run. I'm looking at the cable type. It is critical when it comes to either copper or fiber that the person setting the test up selected the correct fiber or copper type. So here they've chosen OM4 50 micron multi-mode fiber. This shows us our modal bandwidth. This is a description of the fiber's ability to carry data over a distance. Here we see the overall length of the fiber, the overall loss. Now, one of the great advantages of the OTDR is it doesn't show us just the overall loss. The OTDR is going to show us the insertion loss of each of the individual connectors. So in this case, what we see is that we've got the OTDR here at N1. We see we have a launch fiber. So this gray line right here indicates that a launch and tail fiber were used. If we're doing OTDR testing, it's strongly recommended that launch and tail fibers are used. What this does is it pushes the first measurement out far enough that we're able to get an accurate measurement of that first connection. So right here at the end of the launch fiber, we see that we had our first connector. This connector had a loss of 0.2 dB and a reflectance of negative 41 dB. The connector at the far end had a loss of 0.21 and a reflectance of negative 52. Now, reflectance is an important value when we're looking at fiber. This gives us an idea of how much light is being reflected back to the source by that connector. So what happens when I have a connector, I go from glass to air to glass. No matter how tight I get that, I'm going to get a little bit of air in there. And in that case, we see that there is a change in the index of refraction. This causes light to get reflected back. If we get too much light reflected back, this can result in data errors when we start sending data across that link. So we're looking for a reflectance value of less than negative 35 dB for multi-mode, negative 40 dB for single mode, and negative 55 dB if we're using APC connectors. Now what we want to do is we want to make sure that when we call out this test in the test specification, that we require that they look at reflectance if we want OTDR testing done. So we'll come down here. We see that with this cable right here, it shows that we failed. So it shows our information about the testing that was done. It shows the date and the time that the test was completed. One of the things that we promote in our training is that people go out and check the date and time on the tester before they run the test. I get test results every once in a while that come in where the date is 1970, January 1st, 1970. The tester, the battery died, the tester reset back to 1970. The person that ran the test didn't go to the trouble of checking the date and time before they ran the test. This value is burned into the test and it cannot be changed later on. So this is the type of attention to detail that we like to see people doing, is making sure the date and time is set correctly. Now in this case, it tells us the information about the modules that were used to do the testing. So it tells us what our module is. Here's our OTDR module. It tells us what version of code we had on it, and it gives us that calibration date. I am always looking for that calibration date to be within 12 months of the test date. Now again, these are our old test modules that we use in class. We don't recalibrate these every year, so I'm not surprised that there is a 6-year difference in between those test dates. Over here, we see our launch and tail compensation. So in this case, the person that ran the test went to the trouble of setting up launch plus tail compensation. We expect that when we do an OTDR test, that we are going to do launch fiber compensation before that. It gives us the information on the launch fiber, on that launch and tail fiber. Here, it gives us the detailed information about the OTDR test that was run. Okay. So we can come down, we can take a look at what happened in this case. Now, what's interesting is we see, now let's see, we see our test failed in this case. So we're going to go down through the test report. We're going to see what failed on there. So in this case, our overall test summary for this is we failed. Now, if we look at the individual tests, our bidirectional averaging passed. So we can look up here, and this tells us for this cable ID, we had a failure. We can dig in and take a look at each one of our tests and see whether they passed or not. So be careful. There's been cases, we saw one case where somebody copied and pasted green check marks over the X's, tried to make it look like the test passed. Come down here and take a look. Right here we see OTDR bidirectional passed. We see our OTDR on end 1 passed. OTDR on end 2 passed. Now for our OTDR, it is showing our traces at both of our wavelengths. It's important that we see that both wavelengths were tested. Failures at the upper wavelength can indicate a bend or a crack in the fiber, and this may not be picked up by the lower wavelength. We come down here, we see what failed. What failed was our end face inspection. So in the, when we're doing fiber testing, one of the tests that we can do is we can do a fiber inspection test, and we can compare this with a test limit. So in this case, this shows us the raw image. It tells us that end face 1, we failed the test. And here we see why we failed. These red circles right there show us what failed. Here's our raw image. Here's a case where an end face passed. So it is not a bad idea to have end face inspection testing included as part of the testing. Now, if you have MPO connectors, they can use the FI3000 fiber inspection ultrascope to go in and inspect an entire MPO connector end face at the same time. So we see, here's our end face information. We come down here. Here is our Certifiber Pro test. So in this case, what happened? They went in, they ran the test. We see we've got our cable ID, we've got the date and time of the test, we have our cable type. Again, make sure that the correct cable type was selected. It gives us some information about that fiber. Here is the test limit. So in this case, when we ran this test, we selected the TIA 568.3-D-1 multimode test using reference grade test reference cords. So there is a document out on the Fluke Network site. It's the limit lines. It gives us a detail for each one of these test limits. So in this case, what this limit is doing is it is allowing half a dB for the first and last connectors, 0.3 dB for each splice, 3 dB of loss at 850 nanometers for the fiber, and 1.5 dB of loss per kilometer at 1300 nanometers. So over here, it shows our results. So it tells us what our propagation delay was, what the length of the fiber was, shows us what the limit for this fiber is. It shows us that we passed. Our loss was 0.99 dB. Our limit was 1.3 dB. So it used the length of the fiber, number of connectors, number of splices to calculate the length. The limit tells us our margin, gives us our reference values. Now in this case, if we go in and we take a look at the help screen on the Versiv, we would find that our reference value should be between negative 19.4 and negative 26.5 dB. So this is, again, one of those things that I take a look at when I'm looking at a report. Was the reference value what we expect? Now we're going to come over here, and this tells us some information about that test. It says that the number of adapters were 2. This is a connector on one end and a connector on the other. If I had a patch in the middle, I'd have 4 connectors. Get that right, 4, 2 on each end. So the person running the test needs to put in how many connections there are. We have 2. How many splices? In this case, none. What type of connector? SC. Now right in here, I'll tell you, this is such a critical one. Jumper reference. This tells us that the person running the test did a 1 jumper reference. Now, there are 3 options: 1 jumper, 2 jumper, 3 jumper. We push really hard in our training that the acceptable method for setting reference is 1 jumper if we're testing from patch panel to patch panel. We never use 2 jumper. Don't do it. If you're working with ISO limits, that's not even an option. Now 3 jumper, this is where we're doing channel testing and we're testing things like MPO cables. So I would say if you have a project done and they are testing from patch panel to patch panel, look for 1 jumper reference. In fact, I would go so far to say in writing the test specification, require that they use 1 jumper reference. This will give the most accurate test results. Using 2 jumper reference will provide optimistic test results. So these results may not show the actual loss of that connection. In fact, we may even get negative loss with that. We don't want to do that. Now, down here at in this lower section, we see compliant network standards. This shows us which technologies we would expect would run across this fiber. So within LinkWare Live and LinkWare PC, the software goes through and takes a look at these test results. It compares these test results with the limits for each one of these technologies, and it comes back and it prints them down here. So this says that this will, if we want to run 10G base SR, great, it'll run 10G base SR. If we want to run 40G base SR4, this will support 20G base SR4. So we see what technologies would be supported by this. If the person running the test chooses the wrong fiber type up here, that will significantly impact the compliant network standard shown down here. So we need to make sure they chose the right fiber type and that the technology you want to run appears down in this lower section. So now let's zip down here. We've got a lot of tests that we ran on this fiber. Let's run down to our copper test real quick. So here's where we find our copper tests. So in this case, let's go through and see what kind of testing was done on this copper cable. Unfortunately, in this one failed. So we're going to go ahead and take a look at what failed. So just like with the fiber, up here at the top, we see that there's the time and date. So it's a good idea to make sure that the time and date that this test was run matches up with when they were on site. Just a great way to go in and check and make sure that these are your test results. Now here we see our headroom. This is the difference between the test limit and the test result. We can see what test was run. Now in this example, we ran a Cat6a permanent link plus all. Now if we were to come over and look at our adapters show us what adapters were used for doing the test. So let's flip over on our camera right here. And we're going to flip over here and take a look at our adapters real quick. And in fact, I'm going to stop sharing the screen. And we're going to bring these adapters up. I've got these hooked up from a previous session we did. These adapters right here with these big heavy cables, these are what are known as permanent link adapters. And they've got an RJ45 plug there on the end. What this adapter allows us to do is test the RJ45 jack that this is plugged into. So if we're testing from patch panel to wall jack, these are the adapters that must be used. Occasionally, we will see channel adapters show up. Now the channel adapter right there is designed to be used with a patch cord. But here's the thing. That test is only valid if that patch cord is left in place. So if you have the patch cords and those patch cords are going to stay there, it is okay to do a channel test. But if we're taking this patch cord and moving it from one connection to the next, that is an invalid test and it is wrong. So if we were to go back to our report right here and look at our report, if in this case, for this test, we are going from patch panel to patch panel or patch panel to wall jack, the adapter we expect somebody would use is a DSX PLA004 if they're using a DSX 5000 or a PLA 804 if they're using a DSX 8000. So the 5000 uses the 004, the 8000 uses the 804. I look at that, I've gotten test results back I've taken a look at, and I see they're using channel adapters. You can bet the first thing I'm going to do is send an email asking why the channel adapters were used. Why did you use channel adapters in this case? You should not have been running a channel test. You were testing from patch panel to wall jack. Well, the cable wouldn't pass with the permanent link adapter. Oh, channel tests aren't as strict as permanent link tests. So if someone's using a channel adapter, that can indicate that maybe they couldn't quite get that cable to pass with the permanent link. So that's one of the things I look at. Calibration date. This is not optional. This is printed on your report. Make sure that this date right here is within 12 months of your test date right there. Now, as we come down through here, what this is doing is this is going to show us the tests they ran. Now, in this case, we ran a TIA Cat6a permanent link plus all. So this ran a Cat6a test, and it ran all the possible tests. So this tested resistance unbalanced. It tested transverse conversion loss and equal level transverse conversion transform loss in addition to all the regular tests. As we come down and take a look at our copper result, we see the length. This cable is 295 feet long. Now, here our limit was 295. Our pair, 4.5, takes the shortest pair, was 296. Now, did that cause us to fail? Well, let's go through, and actually we want to see what failed here. So in this case, right here, we failed insertion loss. Now, we were just slightly over our length limit. So you say, well, Mike, that failed. TIA 1152A allows us to go over length by 10%. And it does because we could have our nominal velocity of propagation set wrong for this cable. So we had this NVP set to 68.5. The NVP lets us know what the speed of the electrons are compared to the speed of light in a vacuum in the cable. This is used to determine the length of the cable. This isn't set exactly right. The length could be wrong. So in this case, we give a little flexibility when it comes to length. We can be off by 10% and still pass. Here we see our propagation delay. So our limit was set to 498. We measured 463. Okay, so we're good there. Delay skew. This is the difference in bit arrival time between pairs. Here, we were at 44, or our limit was 44. We came out 24. Okay. Resistance. So our resistance limit was 21 ohms. We came in at 12.8. Perfect. We can see our resistance unbalanced. So it shows our limit was 3.70. We were at 0.056. Good. Limit here for pair-to-pair unbalanced, 0.44. We're at 1.4. So our resistance is good. We expect that PoE is going to work okay on this cable. Here's where we failed, insertion loss. So with insertion loss, we are taking and measuring the reduction in signal, the attenuation in signal along the length of the cable. So for our insertion loss, it tells us right here that we failed because we were 0.08 dB over the limit. Now, we are pushing it, and it tells us what frequency it failed. So we failed at 496 megahertz. So up at the top end of this cable, up at the top end of the frequency specification for this. Over here, we have our wire map. So it shows all 4 of our pairs are good. They're wired straight through. And here we see our plot data. When the person is setting up the test, they have the option to turn on plot data or turn off plot data. We strongly encourage plot data to be left turned on. Cable manufacturers expect this for warranty cable installs. Most people looking at the report expect to see these plots. If they send the test results into Fluke Networks for analysis to help solve a problem, they expect to see these plots. And if we're going to do alien crosstalk testing, we need to have these plots out there as well. So these plots show us what our test results are over all the frequencies that we tested. So up here for insertion loss, we see that our lines are tracking the limit line up there at the top pretty tightly, and right up there at the very end, we exceed that just slightly, and that's what caused this cable to fail right here. Now, as we come down, we see that we've got near-end crosstalk. So with near-end crosstalk, we send a signal in one pair and look at how much of that signal bleeds over onto the other pairs. So here it shows us what our near-end crosstalk was. It shows our limit. It shows what we measured. We can see our, how things look in there as far as our near-end crosstalk goes. Tells us our worst pair. So which pairs were worst in there. The thing we're looking for here is pass, pass. Now if we see an NA, so like in this case, attenuation crosstalk ratio near end, this was not required by the standard, but we see the numbers for it. Pass. So if there's a pass, it's required by the test limit we selected. If we see an NA, it was not required, but we get that information about that cable. Okay. So we're going to come through, take a look at that one. So in this one, we come in, we take a look at this cable. Let's see what this one failed on. This cable failed on near-end crosstalk. So right here, we see our failure right there. So it tells us that we failed next. We can look at our next graph. We can see that right around in there, we had some problems with near-end crosstalk. Now, from a troubleshooting standpoint, there's not a lot we can do with the report right here as far as taking a look at what went wrong. We will download this information in the LinkWare PC, and we will go in and take a look at cable ID A02 and see if we can tell what went wrong with that cable. So again, as we go through each one of these, it's going to show us whether we passed or failed. NA, this was not required by the standard. Here, this cable passed. And look at the difference in these cables. Now this cable was only 100 feet long, but we see much better insertion loss right there. Shows us everything that passed. Now, notice right here that the remote adapter is a DSX PC6A. What is a DSX PC6A? That is a patch cord adapter. Now, for this particular test, this was an MPTL test. So an MPTL test is where we have a patch panel on one end and an RJ45 plug on the other. This is becoming a more and more popular way to connect devices such as wireless access points and cameras. So with an MPTL, we crimp an RJ45 plug on the far end. Now this could be one that's crimped on, or it could be a toolless connector, but we put a connector on that far end. Now if the person running the test chooses to use a channel adapter, they cannot run an MPTL test. They would run what's called a modified single connector permanent link. A modified single connector permanent link is not an ANSI TIA recognized standard. This is a Bixby standard. One of the disadvantages of using a channel adapter to do that test is that we do not evaluate the quality of the RJ45 plug at the far end. So if the contractor that runs this test does an MPTL test, they are required by the tester to use a patch cord adapter. The patch cord adapter has the ability to measure near-end crosstalk at that far end plug. Now, you have to choose the correct patch cord adapter for the category of cable you're testing. If you're doing 6A, you need a PC6A. If you're doing 6, you need a PC6. So that's one of the investments that contractor is going to need to do, is make an investment in these patch cord adapters. If they do, you are assured as the person that's having this network installed that they have gone in and tested that far end connector. So if I was writing a test specification, I would make sure that if you're having cables terminated with RJ45 plugs for cameras, for wireless access points, that you call out doing an MPTL test for that, and make sure that the MPTL test limit was selected and that the correct adapter was used here for running that test. So in this case, we see that that test completed successfully. We get all that information back. Okay, now let's scroll way down here. Oh, and as far as compliance standards go, this tells us that this will support up to 10 G-base-T. That's fantastic. That's what we want to see. Now we're going to come down here toward the end of our report. And here's my TRC value. Now, when I'm having fiber testing done, I've mentioned the test reference cord verification results a number of times. Here is where we see those down here at the end of the report, and they show up as info. These aren't pass-fail. But in this case, this is where they did their test reference cord verification. Now, for multi-mode fiber, the limit is 0.15 dB. Here we see that the result was 0.07. That is fantastic. Those are the kind of numbers we want to see. So when you're looking at the report, it's always a good idea to make sure that if you're having fiber tested, that there are at least 2 TRC records in there, and that the value shown here for loss is less than or equal to the limit right there. Now, this report was generated out of LinkWare Live. So let's come out here. I'm going to grab my PC. And we're going to bring over LinkWare PC here. Get rid of that. Get rid of that. All right, so let me share that specifically. So here's LinkWare PC. So one of the things that I can do with LinkWare PC is after I've collected all my information, I can import my test results into LinkWare PC either from a USB drive, via a USB cable. I can connect to the tester using a network connection, or I can get this via LinkWare Live. So from LinkWare PC, which you can download for free from the Fluke network site, you can come in and we can come in here and we can click on LinkWare Live. So it is connecting to LinkWare Live as me. Now I logged in earlier with LinkWare Live, and let's see. I'm going to go back 365 days. We're going to select our sample report. So now what I'm going to do is I'm going to take that information that was uploaded to LinkWare Live, and I'm going to download that to LinkWare PC. Okay, so now here are all my test results. So if you're having testing done, one of the things that you might want to ask for is the LinkWare FLW file, the Fluke LinkWare file. So when the person gets done doing the testing, they can come out here and they can say export to file. We can say auto test reports. We can say all reports, and it is going to create, well, let's see, sorry. I can say save as. There we go. So I can say save as, and I could say sample report. And we're going to hit save. So now I just created the FLW file. So if you get that FLW file as part of your testing, now you can download the LinkWare PC program from Fluke Networks for free and open that file. It's going to give you this level of detail. So we're going to come in, we're going to find one of these cables that failed. Right here. Let's find this one. A02. I'm going to go into detail. So I can see why my wire map is good. If I go into pair data, it's going to show me some information about that. Now, we know from looking at the report that this one failed near-end crosstalk. So what I want to do is I want to go in and see why it failed. Now there's some pretty neat tools in here like our HDTDX, and this will show us information about our cable, and we can start looking for where do we see that failure. Now if I come in here and I look at my values at our connectors at each end, we are looking for 35% or less. So in this case, we've got 10, 20, 30, 40. So if we drew a line at 35, so about right there is about 35. About right there. What we see is that what could be causing our near end crosstalk to fail on this one would be this connector at the near end. So connectors, we don't like to see those over 35%. It gives us an idea of why that failed. Now hopefully nobody's giving you a test report where there's failures on there. If there are, I'd ask why they gave you a report that had failures. All right. So you can get that FLW file and bring that in. So there's a question about the attenuation coefficient on the OTDR. I want to make sure we cover everything on the report here first, and then we can go in and take a look at some of the settings in there as far as what we can set in OTDR on things like coefficient, attenuation coefficient. So what I'd like to do is, let's get rid of that line. Open this up for questions. If you have any questions, I want to make sure that we get those answered. I want to make sure that we covered everything on the report. We cover a lot in our classes on how we go in and set up the tests and run those tests. As far as going in and interpreting those results, that's another area that we don't usually cover in class that I wanted to make sure we covered here. Close that.